Hello and welcome back again. Today, what we're going to be doing is we're going to talk about writing functions, right? So, obviously, writing functions can be a whole lot of different things, right? You could write all sorts of functions. But today, what we're going to be able to do is write a linear function that models the relationship between two quantities, or two variables, I guess, is what we could say. So, we're going to do that. So, we're going to look at a table of values, and we're going to look at a graph, right? You can use either one to help you figure out what a proper equation would be. So we've got this table over on the left, right? And we got that graph over on the right. And what we want to be able to do is make a function out of it, right? So the easiest one, and the one that we're going to focus on today, is trying to get it to look like y equals mx plus b, right? So hopefully you remember from previous math classes that this is called slope-intercept form of a line. So when we're talking about slope-intercept form, right? The slope is that letter M hanging out in the middle. The other piece, this B that's hanging off the end, is our y-intercept, right? So we have an intercept and a slope. That's why we call it slope-intercept, right? When we're talking about it as functions, there's a couple things that we're going to change, right? So instead of having that y out in front, what we would do with that is we would replace it with f of x, right? Because that is our function notation that we talked about a couple lessons ago, right? So, no real big change happening there other than it just looks different, right? So instead of y, we're going to have f of x. We're also going to kind of talk about the slope and the y-intercept a little bit differently, right? So for slope, we want to think about it as a rate of change. Right, so when we're talking about rate of change, right, we're saying like how fast is that quantity changing over time, right? As for the y-intercept piece, we want to think about that as sort of our starting point. Right, so if we think about the rate of change and starting point, that's going to make things a little bit easier for us, right? We're still going to kind of connect that to the graph and the table of values. So let's take a look at the table of values first. All right, so I'm just going to kind of ignore the graph for a minute. If I wanted to figure out what the y-intercept is, what I need to do is I need to figure out where the x column has a 0. Right, so I just look for where it has a 0. My y-intercept is straight across from there. Right, so my y-intercept here is 4. All right, so if I was writing out this equation, I've got the f of x. Right, I've got an equal sign. I don't know what m is yet, but I know I'm going to have an x, and then I'm going to have plus whatever the starting point was. Right, so again, in this case, that turns out to be 4. Right? As far as finding the slope goes, it's a little tricky to do on tables of values, right? So we're going to talk it through. This is hopefully something you've seen in the past. Whoops. Right? But if it's a little unfamiliar, that's okay. We're going to talk it through. So when we're talking about slope and rate of change, right? It's the rise over the run, right? So actually off to the side of here, right? Slope is rise over run, right? And another way to think about that is it's the change in y divided by the change in x, right? So the way that we talk about the change in is we use a Greek letter called delta that's just looking like a little triangle. Let me zoom in on this real quick while we're talking about it. So we're talking about the change in y divided by the change in x, right? So all we're going to do with this table of values is we're going to try and figure out how much is y changing and how much is x changing. So to figure out how much y is changing, we're just going to look how far is it going from one line to the next, right? So to get from 3 to 4, we're saying, all right, it's going up by 1. 4 to 5 is going up by 1, and same thing for 5 to 6, right? So the change in y here is 1. Oops, let me move that a little over to the side. Actually, let's put it down there. All right, so my change in y is 1. My change in x is a little bit different, right? Still going to take a look from one line to the next, but to get from -5 up to 0, I had to go up 5, right? So positive 5. To get from 0 to 5, I had to go plus 5. And from 5 to 10, again, we got plus 5, right? So again, over on the right side, we found the change in y. This was the change in x, so that's going to go on the bottom. So when we get to the end of that, we find that our slope, our rate of change, is 1/5, or 1/5, right? We can also find the same information on our graph, right? So you can see down in the bottom left corner that I've still got 1/5 x plus 4. Right? The way we find these things on a graph, our starting point is the y-intercept. Right? So remember that the y-intercept is where we cross this y-axis, right smack dab in the middle of the graph. So my y-intercept is right there. That's up at 4. Right? So that's where we could get that on a graph. As far as our rate of change goes, right, I have that y-intercept in red. I need to find another good point on the graph that I can kind of count out the slope to. Right, so what I'm looking for is one where it really nicely matches up with the grid lines, or in this case, the dots that are on the graph. What I'm seeing is that that point that I just put there in blue matches up real nice with where the dots are. So to figure out the rate of change, you know, again, I'm just figuring out the rise and the run, the change in y and the change in x. So the rise is to go up 1, right? We had to go up 1 to get from the red point to the blue point. After I do that, I now need to go over 1, 2, 3, 4, 5 points. Oops, let's try and keep it all color-coded for you. All right, so we had to go over 5. So that means that our slope would be 1 over 5, right? Which is exactly what we had down there, right? So y-intercept was 4 in the red. My slope was 1/5. We can get it from either one of these, all right? After that, we're done. That's it. That's all we're looking for, just trying to write that equation. What I would like you to do, right, is try one of those methods to find the y-intercept and the slope. If you need to rewind a little bit and rewatch, or even just if you wanted to like look at this screen here and pause it and have that up while you're trying number 2, go for it, right? But pause it, try out number 2, see what you get, right? Worst case scenario is you're wrong and nobody's even going to know. That's okay. All right, so hopefully you gave that a shot on your own, right? Let's talk about it. So again, what I need to do is I'm trying to come up with something that looks like f of x equals mx plus b, right? Where b is our starting point and m is our rate of change. All right, so that's really what we want to get to. So on the table of values, my starting point is just wherever the x is 0, we just go straight across from there. So my starting point is 7. As far as the rate of change goes, again, I need to figure out how much is the y changing from one to the next on those lines there, right? And every time, it seems like it's going down by 1. So I would say -1 there. As far as the x's go, for the change in x, right, it looks like it's going up by 2 every time, right? So we would say +2, right? So my starting point was that 7 that we had in the red. My rate of change is the change in y divided by the change in x, right? And hopefully that's what we also will find when we take a look at the graphing side of things, right? So if you did the table of values way just like that, awesome, great work. Let's take a look at the graph. On the graph, I'm going to zoom in a little bit more so it's a little easier to see. I need to figure out my starting point, which is where that y-intercept is, right? So I'm going to put that red dot where we cross that y-axis. That is up at 7. Cool. Right, actually, I'm going to move that up there. The next piece that we need is we need to find another point that really lines up nicely with the rest of the graph, right? That one looks pretty okay. And count it out just to see what the rise and run is, all right? So the quote-unquote rise is to go down 1. Because we're going down, it's -1. For the run, we go over by 2. We're going in a positive direction, we'll say +2. Right? So rise -1, run +2. We'd end up with -1/2, which is what we got from the table of values as well. Right? Our last step is simply just to throw it all together. Right? So we're going to say that f of x is equal to that rate of change with an x slapped onto it, and then plus whatever that starting point was, right? I will mention that our starting point is +7. I really should be putting that included as part of the starting point there, right? You can also have negative starting points, right? I could have started my graph down at like -3, right? And then I'd want to have -3 there, right? So hopefully that doesn't seem so bad, right? We're just grabbing information, throwing it all together, right? let's take a look at some that involve word problems, right? So these can be a little trickier, right? But they do give us the information we need. So Gibbs, Tony, Tim, Ziva, Abby, Jimmy, and Ducky, the cast of the hit CBS drama NCIS, went bowling one day after work. Cost the group $15 to rent their shoes, and it cost them $4 for each game, right? So we want to write a linear function in function notation, right? So that already is telling me I want f of x, right? That would model how much money the group would spend, right? So like I've been talking about, right? We're going to try and get this in an mx plus b sort of thing, right? So we need our rate of change and our starting point. So if I go back to the original problem, right? It costs the group $15 to rent their shoes, and it costs them $4 per game. We want to think about which one of those numbers, right? 15 or 4 seems like it's a starting point, right? So what I'm thinking is, say that, we just get to the bowling alley. We haven't actually started bowling yet. We're just walking right in, and all of a sudden they're like, all right, you got to rent your shoes first, right? You don't just start bowling. You got to rent the shoes. So the $15 to rent your shoes is your starting point, right? So it's positive 15, so we'll say plus 15 for that chunk, right? You can fill in all the rest of the stuff that's not changing. The only other piece we need is the rate of change, right? So we're talking about how much money the group is going to spend, right? So, as we play more games, the price is going to go up, right? If you play 40 games, it's going to cost you more than if you play 4 games, right? So what I'm seeing is that $4 per game is our rate of change, right? There's another little trick that we can use, right, that'll help us figure out that that's the rate of change. This word per, P-E-R, right, really helps you narrow down which one of those things is your rate of change a lot of the time, right? Because it's talking about a rate, right? Rate of change, same idea. Okay, so we got a couple other follow-up questions here. If the group plays 3 strings, also known as games, how much money would they spend, right? So a couple things that we're going to do to kind of prepare us for this problem, right? So I'm going to erase what we had there. I'm going to move this up a little bit, right? On your paper, I know that you don't have the ability to do that. So if you want to write it like over to the side here, like somewhere in this space and work on it there, that's not a bad idea. So what we've got here is we have all these different pieces, and we want to figure out now what the x and the f of x are talking about, right? So the x and the f of x, knowing what those are is going to be pretty important for future problems we're going to do. So let's talk about the x first, right? When we're looking at that rate of change, right, that 4 that we have in blue, it's costing them $4 per game, right? So when we're talking about $4 per game, the game is what's getting multiplied by 4, right? Like I was saying, if you play 4 games, 4 times 4 is 16, you're paying that much for all those games. If you played 10 games, that would be 4 times 10, $40 for all those games, right? So X is the number of games played. Oops, let's fix that up a little bit. All right, as far as f of x goes, right, that one can be a little trickier, right? So, if we think about what's going on the right side of the equation, right, 4x plus 15, 4 is talking about money per game, so that's all wrapped into money. 15 is how much we're spending to rent the shoes. So when we add those two together, that's kind of giving us our total cost. Right, so that's what we equal out to on the other side. The total cost of them going bowling is equal to all that stuff on the right side. Right, so the reason that I wanted to pause and do that is because they're telling me, all right, oops, if they're playing 3 games, I want to figure out how much money would they spend. Right, so 3 games, that means that the x, the number of games, is 3. For how much money, that means that we don't know what the f of x is, right? Who knows? Question mark, right? But if we know that x is 3, we can plug that in and we can figure out what f of x is. Right, so I'm going to take that same equation we just had, right, 4x plus 15, and what I'm going to do is I'm going to plug a 3 in for x. So f at 3, right, remember we talked about how to use this function notation to evaluate a couple lessons ago? If you need to go back and refresh, that's okay. All we're really doing is we're plugging that 3 in for x, and we're just going to kind of simplify. F at 3 is equal to, we're going to do 4 times 3, which is 12. And then 12 plus 15 is 27. Right? At the very end, because this is a word problem, we're talking about money, we want to put 27 with a dollar sign. Right? So they would spend $27 overall for that. Right? Last but not least, if the group spends $39, how many games did they play? So they spent $39. That's telling me that my f of x is equal to $39. We don't know how many games they played. So that means that at this time I don't know what the x is. Right? So yeah, we can start this off kind of the same way. We're going to take a look at our original function, f of x equals 4x plus 15. And we're going to plug in the piece that we know. We know in this case that the entire thing, f of x, is equal to 39. So where I have f of x, I'm going to replace it with 39. Right? So after we do that, right, I have 39 equals 4x plus 15. All I got to do is just solve this out, right? It's a two-step equation like we've done in the past. I'm going to subtract that 15 to move it away from where the x's are. 39 minus 15 is going to give us 24. Over on the other side, we still have 4x left over, right? Because those 15s are gone. After that, to get rid of that 4 in front of the x, we have to divide by 4. All right, so that will help us get rid of the 4s, which is what we're going for. 24 divided by 4 is 6, and 6 equals x, right? So when we're down to the end of it, right, x equals 6, they are going to have played 6 games if they spent $39. Right? So if I'm being honest, this is not a particularly easy thing to wrap your brain around at first, right? If you're at a point where this kind of makes some amount of sense, then you're doing great, right? It is not easy. There's a lot going on the page as I'm looking at it right now, but you just take it one step at a time, right? Let's try another one out. Right, and again, like I said, these are not particularly easy. We'll talk through it together. So one bright, sunny afternoon, Ricky and 4 of his friends decided to hike to the summit of Katahdin. The mountain is 5,270 feet tall. Every hour, they're ascending a total of 950 feet. Right, so if they start at an elevation of 250 feet, I want to write a linear function. Right, so again, telling me that I want to do an f of x on this thing that will model their elevation over time. Right, so again, we want f of x, we want an mx plus b sort of thing, right? So mx plus b, right? So first things first, let's try and figure out one of those two missing pieces, the m or the b, right? If I'm reading through this part A again, if they start at an elevation of 250 feet, well, I don't know about you, but that sure sounds like a starting point, right? They're starting at 250 feet. Boom, done. Right? As for the other piece, right, we do have to look a little bit through the rest of the problem to figure out our rate of change. Right? So 4 of his friends, whatever, mountain's that tall, every hour they ascend a total of 950 feet. Right? So if you're doing something every hour, right, it's like you're going 60 miles per hour, right? That is your rate of change. That is telling you how fast your elevation is changing in this case. So my rate of change is 950, right? So that's our function right there, right? We have our starting point at 250. We know we're going up 950 per hour. And then the only other piece that I want to make sure we take care of is making sure we know what x and f of x are talking about, right? So we know that, 950 times however many hours. Oh, sorry, I almost gave it away. 950 is talking about how far we're ascending. 250 is where we started. It's talking about elevation overall on the right. If we add 2 elevations together, that's going to give us our total elevation. Right, so that's what f of x is equaling out to. Over on the right side, to figure out what x is, right, again, take a look at where you found your rate of change, right? It was 950. So we're saying that every hour they ascend a total of 950 feet. Right? So if it was 1 hour, I would have gone 950 feet. If it was 2 hours, I would have done that again, twice. So what we can say is that x is the number of hours. Right? And again, this is probably the harder part of all this. It does get easier the more you practice with it, right? So please make sure to try out some practice problems, right? Even if you wanted to try the rest of this problem on your own, I would encourage you to pause here, give it a shot, see how it goes, right? It's not going to hurt, I promise. So for part B, we want to figure out what will their elevation be, right? Which means that I have no idea what their total elevation is, right? That's a question mark. After 4 hours, right? They're giving me the number of hours to be 4. So again, all I'm going to do is I'm going to take our original function. I'm going to plug in a 4 wherever I had an x. And then just go from there. All right, let me move this a little off to the side so it's a little further away from some of that other stuff. All right. So 950 times 4. It's going to give me, ooh, what's that going to be? Let's break out the handy-dandy calculator. 950 times 4. 3,800. Always better to check than not. Plus 250. And then if I go ahead and add those two numbers together, I should get 4,050. All right, again, we're talking about height. We're talking about elevation. So I want to put feet on there. So we're at 4,050 feet after 4 hours of hiking. That sounds pretty good. It's not so bad. All right. Last but not least, we got one question left we're going to talk about. How many hours will it take them to reach the summit? So how many hours is telling me that I don't know what x is, right? If we're reaching the summit, right, then we got to go a little further back in the problem again, right? The mountain is 5,270 feet tall, right? So if we've reached the summit, that means that my total elevation is 5,270. Oops, let's clean that up a little bit. All right, so again, what we're going to do is we're going to take our original function up there with the red and blue in it, and I'm going to just replace the pieces that I know. I know that f of x is 5,270. Oops, and the pen's freaking itself out a little bit again. Sorry about that. That's equal to 950x plus 250, right? Because the f of x is the only part we knew. Everything else stayed the same, right? Just like the last time we ran into one like this, it's just a two-step equation. The numbers are real big, which can be a little scary, right? But let's take it one step at a time. Subtract 250 from each side to help us move that over to the other side. So we're going to get 5,020 there equals 950x. All right, and remember, those 250s are gone. To get rid of that 950, we need to divide by 950 on each side. So 5,020 divided by 950. Let's check it out. 5020 divided by 950 is 5 27/95. All right, so let's see if we can get that a little bit nicer. Let's call it 3. That seems much better. 5.3 is equal to x. Cool. All right, so 5.3, and again, we're talking about time. We're talking about it in hours. So 5.3 hours is how long it'll take to reach the summit. All right. So, like I was saying, this is not the super easiest thing we're doing in this unit, right? So if you need a little bit of help, be sure to ask for it, right? Give some practice problems a shot when we're in person and all that, and I'll see you next time. See ya!